All right. Hi, everybody. Hi, Matt 2504. We've got a day of a lot of, well, a lot. Two is infinitely more than one. So UQ Ventures, who here wants to open a startup one day? Just a bit. Okay, that's okay. That's all good. Does anybody have a startup? Do we have any CEOs in the room? Not yet. Okay, I'll leave it with you.
Oh, thanks.
And yeah, you could just.
Oh, thank you.
All right.
Hey, everyone online. Hey, everyone in the room. Thanks. I'm only gonna be 5 minutes. Is everyone here studying food, like food science? Just mathematics? Okay, that's actually really cool because what I wanted to share with you today in general is what UQ Ventures does. Because yes, we do startups, but maybe one of you wanted to be a leader, make some decisions, make something useful that people care about.
Yes.
So how we help you do that is by being a free service by the university that connects you with people that maybe, if you're interested in something specific, wanting to apply the insights. I'm really generalizing. What do you do in math? Can someone just shout out what you do in math right now? Like, what do you want to actually apply math to?
I'm moving from another program to math because I want to use more statistical modeling, but I'm not necessarily willing to go all the way through a PhD. But I thought it would be important to finish, at least complete the Bachelor of Mathematics. Yeah.
No, it's really cool. One that comes to mind right now that just came through our programs as a PhD student, granted, but is Recovery Metrics, who is using statistical analysis to link towards some early indicators of mental illness related towards mental illness in general. And they're doing amazing. What I'm trying to say is that you have skills in mathematics that no one else has. Honestly, if you take a step out of this room or out of your program or your cohort, suddenly it gets a lot less mathematical. So you have these insights that no one else has. If you wanted to apply that in a new way, meet some other people, see how maybe you get inspired in a new way to apply it. We have these free programs that are starting in a couple of weeks. We can help you. There's a program called Curiosity that where we teach you how to design for humans, where we teach you how to prototype, where we teach you how to pitch and storytell. If that's interesting to you, check out Curiosity. If you're too busy, you only can come to one. Maybe you only want to see what prototyping really is. That's okay. We're just free. We're here. We're going to be back next semester. We have these really cool challenges, though, that I also wanted to shout out really quick. Empower, specifically for women identifying people, to connect you with leaders in industries, give you advice, help you maybe advance your career, build your network. Is that like, you don't have to start a startup. In fact, design thinking, has anyone heard of that? Design thinking can get you a job. I did it before I got here, but it's really just about designing for humans, talking to people before you make something and roll out a whole solution for people. The main reason why startups fail is because no one wants their product, which is crazy, right? Spend years of your time, lots of money. No one wants the thing you made because you didn't talk to people or you didn't solve a big enough problem that people care about. So if that sounds interesting to you and you want to get into a room where other people find that interesting and are working on stuff, and then boom, you come in with your unique skill set, I think it'd be great for you. This is brand new, the Food Innovation Challenge. Kind of why I asked if you're in food, because I know the food students have been starving for a program. Thank you, thank you. Uh, the kinds of people that are coming to this one specifically is like insane. I can't believe the mentors we're getting. It's like founders of like big brands you're seeing in Woolies in BWS, in like maybe a restaurant, like really cool. So if you like food, you should check that out because absolutely insights matter. Big data matters. Sorry, I'm generalizing about math, but I'm just saying unique skill set here. Thank you so much for your time. We're Ventures. We're open all year round. Thanks for your time.
Where do we find you? Where are you located physically?
So right when you come out walking UQ Lakes, we have that building GCI, building 20. It's called the Global Change Building.
Right. Yeah.
That's like, yeah, thank you so much.
Sorry, I've left you so little time. You could have done this for more. Yeah, so thanks a lot. Yeah, look, I mean, I must say that, you know, it's an opportunity to even just stop by and see. It's even as a social club as a start, but then, you know, pick up some skills, etc., product market fit, and the works. So thanks again. Let's just a round of applause.
Oh, thanks.
All right, thanks.
I just have to get my USB, sorry.
USB. Yeah, sorry, it's so short. It's just stingy on the time. Okay, take care. See ya. Okay, so startup. I tried to be an entrepreneur a couple of years ago. It was very hard while juggling with UQ and what my my startup company. Oh, actually, the YouTube channel of this course called One on Epsilon is kind of what's left of this dead startup, right? So we put 2 iOS apps. It was kind of fun, but we didn't have this thing called product market fit. You know, had a great idea, thought of solving a problem, etc., and working nights and learning a bunch of things. It was exciting, got people involved, but product market fit. So these guys are good at that. And in general, yeah, like food. Anybody doing here operations research? So third year maybe you'll do, right? In math, you can actually, you know, the classic problem in operations research is kind of the diet problem of optimizing food in a very mathematical way. But anyway, it'd be great that math would have more of an imprint in UQ Ventures because we have a lot to offer. Or not. Okay, enough blah, blah. Are there any questions as I set up here? Okay, no questions of, let's see. Yeah. While I'm on this, share desktop. What am I doing wrong? Nothing. Okay. So we are in our 4th hour of Unit 1, right? Hello World Bootcamp. And unfortunately, it's the last hour. I'd like to continue a bit more, but you're going to get to the real deal soon. Everybody got the point that in about 50 minutes, we'll have here Dr. Megan Dawson. That'll be the perspective seminar. Please engage in that seminar if you see fit. The more, the better. Intermediate, during, etc. And our goal with this unit, of course, it's the first time we've run this unit. Our goal was that at the end, let's just go to the end because we'll probably, I have a feeling that I'll be picking up the pace of it, right? And tomorrow we'll do a practice quiz and then discuss after the practice quiz. I promise to give you value for time tomorrow. So the practice quiz, and then it's not just a solution. We'll kind of try and, you know, increase your knowledge in one way or another. And we'll part at Friends tomorrow at 7 p.m. and you go off to the next lecture next week, Dr. Paul Bellet, okay? And that will kind of be a step back on computer science, etc., and bits and the works. So the thought about this unit was that at the end, we could do stuff like this. We actually don't have time, and this is not part of the assessment. But before I even continue on kind of the boot camp and Julia, I'd like that we just discuss this a bit. So maybe I'll just zoom in, and what we see here is something that looks like a micro project, but it's also kind of, you can call it a requirement specification. It kind of says, hey, write a program. This is what the program does, right? I mean, that's what your big homework is set of questions like this, but not exactly, a bit more mathematical. But this is, write for me an app, right? This is a very standard app. So this app is a game. Okay, 5 plus 7, what's your answer? And I hit 11 and it says, you're wrong, or I hit 12 and it says correct. Okay. So just from a programming perspective, what's kind of the main, in such, you see how it would work? Can you visualize it, right? It's textual, right? What is 5 plus 7? You answer 12, you get correct or not correct. Next question. I mean, this is not startup material, just to be clear, okay? And don't try to go to market with this one. So what is the main kind of thing that this thing's going to be doing over again? Is it going to be kind of a conditional statement outside, or a loop, or it's going to do a loop, right? So if you, what would I use? Say again? While I'm still running, right? So here's already, there's kind of a choice. So there's a for and the while. So while I'm running might be while I'm running, and it says, hey, as I answer the question, I can also say press Q or something like that, and that would be quit, right? But if I wanted to go for a fixed kind of 5 questions, what would be the natural thing to use? A for loop, right? For iteration 1 to 5, right? And in that loop, I'm going to basically do two main, well, what are the 3 main things I'm going to do in each iteration of this loop? Print a question, read an input, compare the input, right? So that's 3, maybe there's one more. What's one more? Print. Yeah, yes, you say?
Sorry, print
result, right? And generate the question too, right? So to be a kind of this, so in the most basic way, so let's just make the outer loop. Let's make the skeleton for this thing. Okay. Okay, so we'll make kind of an outer loop for this thing. About the basic thing, this thing has a loop. So many programs are a loop, or in a sense a loop, right? Now keep in mind, some programs that we're not doing in this course are actually a different type of loop. They're kind of like, when you run an app, the app typically kind of waits, right? Or when you work with Microsoft Word, it waits. Now you can think of it as a loop that's all the time kind of waiting. Hey, check input, check input, check input, check input, but it's not really doing that. It's a different type of programming. It's responsive, right? Something changes. You click a button, it runs some code. You click another button, it runs some code. But the programs we're doing in this course are mostly kind of procedural, and there's typically some form of outer loop, right? So this will be my skeleton number quiz. So I'll do, say, for this in 1 to 5. And then I'll do roughly, like you said, 4 things. So I'll generate question. Now, often when I program, I actually put notes before I actually start to write the code, right? So there's going to be like notes, like comments. Generate question, print the question, get user input, and compare input and log stats. Okay, something like that, right? It can be something of this order. So let's do like a very simple one. So let's just do x comma y equals rand 1 to 10 2. Now here I'm using kind of prior knowledge. I actually know that one of the methods of the rand function, if I give it 1 to 10, it'll give me a random integer 1 to 10. What does a 2 mean? Going to give me 2 values, right? I'm actually not even sure that works. So sometimes, often when you program, you kind of write your main program, but then on the side, either on a Julia REPL or someplace else, you can kind of test. So let's see, if I do x comma y equals rand 1, 10, 2, will this thing work? Because rand 1 to 10, okay. So do I have something in x? I'm not even sure that this is what we wanted. Yeah, and do I have something in y? Yeah. Okay. So x and y. So these are like the 2 x's. And then I'll print the question. I'll say print len. What is the sum of x and y? Is this thing going to work? Is this going to do what I want to do? Why not? Right. Right, exactly. Now, does my user, this program is aimed at kind of a primary school child. Do they actually need to know that the variable names are X and Y? No, it's internal, right? It's not. So what do I do? Dollar, right. So in Julia, dollar is a way of actually in this string embedding kind of the values of X and Y. Okay, now there's the common way that, so back like 20 years ago when I worked as a software engineer first time, before PhD 22 years ago, that was back in Israel, it would be these programs that run on hardware devices. So you would write the program and then you have to go to the lab and you have to put it on the hardware device and then you have to go out of the lab. So you have to do a lot of thinking before. But now, certainly in this space, we're much luckier. We don't need this kind of development and then going and testing and development. We can test immediately. So a general good rule of thumb is the minute that something runs, that something is runnable and has some basic functionality, run it. Are we in that point? Yeah. Well, so we look at this and then we play this little game between us and our little Frankenstein that we've created, this program. We say, hey, what are you going to do? And we get kind of reassurance. Is this going to do what we wanted it to do? So for example, I might have, for example, forgotten this, but let's say I didn't forget this. And I'd say, well, what is it going to do? Well, I'd want it to print 5 lines. In each line, I'd want it to print what is the sum of some random number between 1 and 10, 1 and 10. Then I'm saying, okay, good, I'm going to run it. I'm running it. Oh, and I see it didn't work. So then, is this, by the way, a syntax error? It's a logical error, right? So it's not it's syntax in a sense, but it's not getting the logic I want. I mean, it's not like if I did this, right? Because this is also possible, right? So if I run this, I'm going to run it, and then I get a syntax error. Which one do you prefer to get, by the way? So who prefers the first error? Raise your hand. Who prefers the second error? The second error is red and it's angry at you. But you're getting smacked, right? And you know you're going to overcome this, right? Logical errors, believe me, you will be spending on project 1 a lot of time. Syntax will be okay, but logical errors will be harder, right? Okay, so let's fix our syntax error. Okay, we're back to the logical error. The program's not doing what we expected. Let's fix our logical error. Okay, good. So we've got some basic functionality. So we're not going to go through the whole thing, but then let's just get user input. So this is, again, user input is not something we do in the course notes because the course note creation would be stuck. But in Julia, the way you do it is you do answer, say the name of the variable, read line. Okay, so let me run this. Now it says, what is the sum of 1 and 8? And actually here in Jupyter, I get something that looks like this, says STD, and now I can kind of print something like that, right? So I'm going to print just Yellowstone, something. It should have been a number, but I'm a user. I can do anything I want, right? Okay. And what happened? Well, Yellowstone went into answer, but nothing else. All right. So that's how we get the answer. But of course, what as a user I would have wanted, what is the sum of 10 and 1? Let's say I'm a smart user and I'll say 11. Okay. So then let me stop this. Now, how to stop this? Here, stop like this. I hope I can stop it. I must tell you, it's not something I often do. Run I have to restart the kernel. That sucks. It's not something I often do. Run with like read line in Jupyter. Okay. So if this would have been in the REPL, it would have been Control C. But here I see. Let's just restart the kernel. So restart the kernel is kind of like closing Julia under the hood and restarting Julia again. Okay. So now let's delete this cell. Let's run this. Okay. Oh, but now I'm stuck again. Okay. So let's kernel, restart the kernel. Okay. So the next thing I would have wanted was now to say if, so maybe here, maybe when we generate the question, we might have also generated a helper variable, correct answer equals X plus Y, right? So it kind of lives in this area. That kind of makes sense, right? And then compare input and log stats. Well, what I would want to do logically is if answer, what would it be? Equals to correct answer. Then say println, good job. Else, println, not so good. Now, of course, I could have said not so good. The sum of X and Y is correct answer and not answer. However, all this is not going to work exactly, but we'll, okay. So you see kind of the program kind of runs and you do, well, runs kind of from programmer to program, yada, 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 and you just, let me just now change the number of iterations just to one. So often, and this you'll see in your projects and homework as well, right? Often you do something and you want it to run along either a long compute or user input. There's not too much user input in this course, right? But you don't want to go through a testing phase all the time. So we realize that testing like on one iteration is enough. And then when we want to, we can change this number or we can make it a parameter or a user setting or something like that. Okay, so I'm going to run this. What is the sum of 9 and 1? So let me put 10. And what should it do? Well, what would we like it to do? Good job. What do you think we'll get? Yeah.
Error string and an integer.
Right.
Either give you an error or say.
Okay, perfect. Okay. You think an error? I think it'll be not the same, but I also live in this kind of twilight. So the answer here is thank you, is right. This thing is going to, even though 10 is the right thing, what it's going to do, we'll see in a sec. Will is, oh, what did I do? Sorry, I should do enter. Not so good. The sum of 9 and 1 is 10 and not 10. Okay, all right. Not a program to write home about just yet. Okay, so, and what was your name again? Rowan, thanks, Rowan. So what Rowan said is it was doing this 10 equals 10, right? Because if I do answer equals read line, so let's do test answer equals read line and run this and I write 10. And now let's do type of test answer. I'm going to get a string, okay? Now, actually, in one of the questions in big homework, you have this very fundamental. It's very kind of basic, important question to do, which is take a string, which is a number. Although just because, you know, you guys are mathematicians, computer scientists soon, et cetera, a whole bunch of things, that number is not going to be in decimal. It's going to be in binary or hexadecimal. And you need to parse it and get the value of the number, right? This is just 10 in the digits 10, right? Invented, I think, you know, by the Arabs about 1,000 years ago or something like that. Indians through Arabs, the whole history of that, right? The decimal system. What we want is the number 10, the 10 fingers, okay? So there is a function called parse, which does this built in. So I think if we do, so if I look at parse int 1, 2, 3, 4, it returns 1, 2, 3, 4. So if I do parse into an int, the string 10, it's going to give me 10. And if I do parse into an int, the string hello, it's probably going to give me an error. What was this? Was this a syntax error? What kind of error? Or a logical error? Or maybe a runtime error? If you've never heard of, so these three: runtime error, logical error, syntax error. It's runtime. Yeah, it's a runtime. It's an exception from the point of the people who did parse, right? The people who did parse, the good folk that contributed to Julia, right? And put it up in Julia, right? They made it so if parse gets something that cannot be an integer, then they're going to give an error. Okay, so now that we know how to parse, where are we? What's the one change to this program that would make it functional? And wait, what do I do? Escape L, escape Shift L. Escape Shift L. No, I don't know. Toggle view line numbers. Show line. I don't know why it didn't work. Okay, anyway, what line am I going to modify? Say one line, which one? 15, that's one way. Okay, right. So then there's some choices, right? So programs are not exactly mathematical questions that have one solution, right? There's actually many solutions. So one option would be to put parse around this, and this would be the answer in string form. right? And a different one might be to do it here, put parse around this. So actually, what I would have liked to do is I would have called that user input. And then I would have liked to maybe get answer equals parse of user input. It never hurts to define more variables, right? So what's the type of user input? What's the type of answer? Yeah, I think I used it wrong. I should have put an int here, right? And by the way, this is kind of interesting, just one step above. Look, the first parameter passed to the parse function is actually the type int. So types are also variables, variable values. Well, they're also constants in the program that you can think. Okay, so that's answer. And doing this might be good in a sense, because then I can do if user input equals, for example, Q, then let's quit the loop. Oh my God, how do we quit a loop? Somebody should know from one. Break, right? I didn't speak about it, but you guys know, some people know break, right? So what is it? Who's never seen break? Some, perfect. That's the best thing. So you run a loop for 5 iterations, but in the middle you decide I've had enough. Okay, so that's break. So where does break go? The program execution goes to the end of the loop. Okay, very good in a while loop, by the way, right? So I like to do, yeah.
We change like the actual answer to a string.
We can. I wouldn't find it the best choice, but it's possible, right? But here's another alternative. And again, I don't know why I didn't find it the best choice. Why should answer to a string? Because kind of comparing the numerical value seems to me natural, but I don't have any really strong disposition on that. But yes, so indeed there would have been. So, but that's actually, what's your name? DR. Okay, thanks. So DR's question was about the answer. Now DR's question or comment is we can actually make 2 changes here. If we wouldn't have done this, we could have done one thing would have been parse int answer equals correct answer. And a different thing could have been, I'll just write as alternative, if answer equals, so one way to do this can be like this, right? So this is kind of the opposite of parse. This takes answer and makes it a string, or I believe we can just use the string function. String of 24 is a string 24, right? Or we could have done it like this. Whoops, sorry. So now there's too many things happening, of course, right? So I could have done string. Yeah, like that. Right, so all these would have been valid. And as you do homework, etc., you're going to go between these things. So sometimes just keep things in comments. So you've got 2 types of comments. Some is code that you thought of and it doesn't exactly work. And some of his comments that really kind of says what the bit below does. Okay, so we're doing, but thanks, that's very good. Okay, so if user input equals Q, then break, answer equals parse int. If answer equals correct answer. And let's run this now for 5 times. We've got a quit, so we're happy. Okay, what is the sum of 9 and 1? Let's do a Q, enter. It stopped, okay? Stopped, right? Okay, we could have done a println bye-bye, etc. Now, in terms of just user input, what would you change in this line just to make this look maybe a bit more streamlined, the way it feels from a user interface perspective? Say again? Simple path, what do you mean? Oh, symbol. Oh, I see. What is, all right. What is, right. So what you're saying is you change the whole thing enough with these words, and I like it. So equals like this, for example. Okay, right. And another one maybe is to remove just a print, not a println. Let's see how this looks. Okay, so if this was running in the terminal, let's run this in the terminal. So 2 plus 3 equals 5. I mean, this is now top notch. Good job. 10 plus 8 equals 9,900. Not so good. Okay, etc., etc. This Q enough. Okay, that's it. So you know how to do this program, right? Any questions? Yeah. Oh, good question. So what you're saying is, does parse int, I'm not sure actually, of like this 10, this, yeah, okay. I would have expected there was actually, we'd need to remove the white space, but no, I guess it does. I didn't know this. Yeah. Oh, okay. So what would be that's an interesting thing too. Okay, it doesn't like it. And 10.0, these are things I don't know. Okay, it doesn't like it. But if I do a parse of the float, so something a bit kind of in Julia, a bit of a not so nice. You do have an int, but you don't have a float. You have a float 64. Okay, so you can't, like int is this int, which is sometimes in 32, sometimes in 64, mostly in 64. Okay, all right, we could explore all day the parse, but okay, yeah.
So, or handles spaces well, but not necessarily the int. Is that what?
No, I mean, okay, we saw here a few things. So what we saw is that if you tell it if you give it a string, which is a floating point number in nature, it's not going to say, hey, it's a floating point number, but I can round it without loss to an int, and you know, they could have made parse like that. So it says no. In fact, you know, you can't have this is not a base 10 digit. Doesn't like it. But what I'm saying is now we'd like to parse it as a float. But if you would have showed me this and said doesn't work, I would have said, instead of int, write float. But if I write parse float, because there's not even a type float. So if I do float tab, I get a completion. This is what in my system, which is kind of float 16, float 32, float 64. There is a type real. You'll get to that with Claire Foster. Real is an abstract type. So both int and float are a real, right? And both on all of these, including complex, are a number. There is something called a type hierarchy, early days for that. Okay. Okay. So now let's go back and just cover a bit of what we need, which we didn't do. And we stopped here, I believe. So this is kind of a big deal, right? And now a lot of you have programmed in one way or another, but some have not. So creating your own function is a big deal, right? Parse was a given function. We get functions from packages or we get built-in functions. This is creating our own function. I think we did this, okay? The return keyword says what the function gives back, right? And the way to view a function is you kind of think in your computer memory, you've got like the computer code, and code runs in different ways. And you create a function, you kind of put some chunk of code that's someplace. And every time you call this function or invoke that function or use that function, these are all synonyms of the same thing, call, use, invoke, you run that bit of code, okay? And sometimes you give the function an argument. So here's the function, my absolute value. Okay, these two things are of course the same, because if this doesn't happen, then you will be here. Is it clear to everybody? So it's kind of a good general exercise, and also for quizzing. It's kind of for code inspection, and it actually makes you kind of a better developer as well. So kind of looking at two bits of code, are they the same or not, right? Do they execute the same? So I'm claiming that this one is like this one, right? So why? So I kind of know how if else works. So I say, if this happens, then you do this, else you do that. So I never get after the if else, right? So say if I had the function, let's just do it. Okay, let's just do a quit here. And let's go down here. If I had the function, and I'll do println, I've got the answer to everything. Will this ever be printed? No, because in both of the execution paths, I leave the program, right? An execution path is kind of where does a program look at any given time. I mean, the whole concept of execution, there is something called an instruction pointer in memory, and it's pointing to the next thing to do, but it's doing it kind of, you'll speak about that more with the other lectures. Okay. Mhm. So yeah, if I would have done here, you know, show x and show minus x, then line either in every time I call this function, either line 3 or line 5 runs, and always line 7 runs. Whereas if I do return, then the way the return, what the return is like, return from running the function back to whatever you were doing before. Okay, so I'm doing a weather simulation. It's very complex. I use an absolute value function. Instruction runs the function and then return, get it back. And it's not just return, it's also give this thing back. So return means to return yourself and what you return. Right, it stops the function and it takes that value as a return value. Okay, so let's make like a very simple function my age, and I just do return 50. So every time I run my age, this thing is 50, right? So and I can do my age plus my age, right? And these are valid expressions. Yes. No, so it's, thanks for the question. So break and return are kind of from the same family. They're both from the give me a break family type of thing, right? But return is out of the function. Break is out of the nested loop you are running, the closest loop you are running in. Right. The reason I say this, we actually didn't do this, but you'll do it elsewhere, of course. For I in 1 to 10, for j in 1 to 10, println ij. Let me make this 3, if you don't mind. How many lines are going to be printed here? 9, right? So, right. And if I do a break here, so break is going to look for the closest loop it's in. And is j ever going to be 2 here? No, is 1, and that's it. And we finished, right? So then we just get, sorry, let me print it like this, if you don't mind. So let's do I equals I, j equals j. Okay. And if I do a break here, then how many lines, what's going to be printed? Right, so I will be 1 and j will be 1, 2, 3. Perfect. Okay, that's break. Yeah. Mhm. Yeah. Okay, sure. So, okay, so back to functions, break with the loops functions, but right, so return and return. So break is for loops. Thanks for the question. And return, sorry, break is for loops. There's, by the way, if we're here, sorry, we'll get back to this question in a second. What's a friend of break? Does anybody know? Much less common. Continue. Yeah, continue. What continue does is it doesn't stop running the loop, but it goes to the top of the loop. Okay, sorry, we have to demonstrate this a second. For I in 1 to 10, if I modulo, if I modulo 5 equals 0, so if then, well, let's see, if I, whatever, well, 4 equals 0, println I, I'm not sure what I'm doing here, we'll see in a sec, and else continue. Okay, so this is really a function. I created some program. I'm not even sure what it does. So let's actually try to understand what it does. After we've also, well, if who's never met continue? Some have never met continue, right? And some of you have met continue. Okay, so let's continue. Get it? It's okay. All right. So what is it? Let's start to run this in our head. I going 1 to 10. I modulo 4, 1, the modulo 4 equals 0. No, I mean, first of all, so instead of running this in our head, let's then convert this to a comment. What sometimes I like, if there's an if like this, I can put a comment. I can say, if divisible by 4, i.e. 0, 4, 8, 12, etc. Right? I mean, only if that's happening, then we're, okay, so we're going to print len I. We're going to print len 1, right? if you have an if else, this thing's never going to happen. Next iteration, we're going to print len 2. Next iteration, we're going to print len 3. Next iteration, we're going to print len 4. Are we going to print len 4? Well, this continue is a bit stupid. Sorry, I'm going to do one more thing. Yeah, okay. So it's just a bad example. So let's do println haha. Okay, we're going to println 1 haha, 2 haha. Yeah,
You're only gonna print the number if it's
right. Okay, so we're not going to print haha if it's a multiple of 4, right? So we'll do 1 haha.
will print.
So if it's a multiple of 4, if I divisible 4 is 0, then, oh, you're right. Sorry, I made it all wrong. Okay, thank you. Okay, good. Okay, so you're right and I was wrong. All right, so now there's a lot of mischief around this program. Problem is it's not going anywhere, but let's see in a second. So is 1 divisible by 4? No. Is 2, so continue. No, haha. Is 2 divisible by 4? No. Is 3 divisible by 4? No. Is 4 divisible by 4? Yes. So println 4, not doing the continue and doing haha. Okay, this was the worst example so far, but you got it. Okay, but that's continue, not so common. I mean, then this is not the way you somehow wanted. You don't want to do the rest of the loop. You want to go to the start. Not so important. Now back to functions, which is where we were. So the question. So and then just before we answer the question, so return takes leaves a function and also returns something. And I might as well at this point also say that we can do, there's an example like this, but let's do it. Function print my story, println, it is a tough one, return nothing. Look, nothing is like a value. You can do nothing. You see, there's nothing. There's a few of these things at Julia. There's not a number, but there's nothing is like really nothing, but it still exists. Okay, I mean, you probably have others. Everybody likes this because we all want to be philosophers and not programmers. The type of nothing is capital nothing, all kinds of stuff like this. Okay, but the point is return nothing is it's if I now do this is a function that's going to print my story, but it's not the type of function that's computing something for me. I just need that return nothing to leave the function. Okay, so functions that don't have a return value, they still run and finish, right? They run and finish, they do stuff, they print stuff, they change stuff in memory, but they don't have a return value. Now, to your question, yes, in Julia, when you do a function, so if I do a function, my computation, and I do X, and I'm not, again, the function is very boring. I'm just going to print len X, okay? And if I do my computation on hello, it's going to print hello. If I do my computation on 354, it's going to print 354. That's all nice and good, all right? Now, I could have defined the function as my computation, but say I want X to be an integer. So what I use is this notation is X is an integer. Okay, so now, well, this, the thing is, let me now kernel restart. So to kill this function, there's no immediate way to kind of reset things in Julia. You need to restart the kernel. So I'm going to do again my computation xint. Now I'll do my computation of 22. Sorry, I think I converted that to a markdown cell. Code 22. Let's do my computation of hello. Okay, so there is no my computation that gets a string. Okay, because my computation was kind of specific for integers. Okay, and as you one sec, as you progress kind of in the course, you're going to work more and more with types, and you'll already see it in some of the examples. So this kind of has a meaning to kind of say, hey, does a few things. First of all, it ensures we don't use the function in the wrong way. If it's meant to work with integers, but not with other things, let's just say integers. It also actually helps the compiler know that this is an integer. The functions actually run faster in a sense. And it also has to do with something called multiple dispatch, which is the Julia way of doing something like object-oriented, which is to run many versions of my computation. Okay. Yeah, what were you going to ask?
If you specify access to the string and then do my computation of 22, well, the string 22.
No, so if I would run, it's not going to do what's called a promotion from an integer to a string, right? So the question was, so I'm going to restart the kernel, okay, to kind of have so again, there's a lot of, of course, no, so you don't have to know the answer to everything, right? This type of stuff, right? This is not kind of quiz level stuff, right? So it's kind of, this is nuanced, right? So the question was, if I do my computation of a string, I mean, if I now do my computation of 22, what am I giving to my computation? An integer, right? We could have thought that the language would take that integer and do something like, hey, well, we can represent that integer as a string, right? But no, it's going to say, hey, I don't have my computation on integer. Only the one nice thing in Julia is if we're here, so your question there in the back, open a can of worms, I can also do my computation of int. And look, if I do now methods of my computation, then I've actually got two different ways of doing my computation. And so it's very annoying in other languages that you got kind of a function name and it has to have a specific set of inputs. Sometimes you could do one computation on the string, sometimes on the ints, and I can do them differently. So I can say that my computation on the string, I'll say computing the string x, and so run this again. So this redefines the function too. This kind of recompiles the function, puts kind of this newer version of it. And then I'll say computing the integer x. Okay, so if I go now, my computation 22, computing the integer x. If I'm doing my computation 22, computing the string x. So you got two different bits of code that ran through. This is one of the selling points of Julia. Other languages have it, but only on the first argument. Julia does it kind of on all the arguments, and that's kind of how you get generic stuff. And Julia, way too early for us now to speak of this. Okay, all right. So, and just if we're here, sorry, it's all very tempting. 22 plus 3im. So we can do my computation on complex. So what do you see here? What's the type that it sort of got? This is even more advanced. Well, this is way beyond bootcamp stuff, but you'll get this. So complex is like a parametric type. You can have complex parameterized by an int64. Okay, so because you can have complex where the numbers are integers, you can have complex where numbers are floating points. Okay, that type of stuff. All right, so we're going to take a break in a microsec, and then that's it. We're done with this. What we didn't do is arrays, but you'll have that in Practical B this week quite a lot. All right. I just say one word, that a vector is a synonym of a one-dimensional array, Julia. And my suggestion, especially for those that have tomorrow's practice quiz should be a bit of a kind of a place, get pen and paper, do the quiz. If you're at home, I'll put it online just before lecture. You can do it at home as well, not the real quiz. Okay, unless special conditions, right? The practice quiz. So why practice quiz? To kind of get to some sort of level. And then we'll discuss a bit more. So you can maybe just go over these questions for the practice quiz, right? And you don't need the answers. You just kind of well, for most of them you can just try, right? But the practice quiz is pen and paper. Any final thoughts, questions? Yes.
The global variable function.
Yeah, so global variable is a bit of a can of worms. So basically, okay, so it's a big question, and so okay, I'm gonna steal 2 seconds. All right, so if I do function my stuff, and I do x equals 22, print len x. Again, very boring function. Okay, end. All right. So if I run my stuff, of course, I'm going to see 22. Now let's define x outside and let's put x as 88. Okay. So I'm going to do my stuff. What are we going to see? 88 or 22? 22, because x is kind of, the name of x inside the function, not outside. So we do my stuff, we see 22. Now, I could have done my stuff and I could have said global x. I said, hey, my stuff, and global variables are not good to use for many reasons. You'll hear more of that, etc. There is some variable outside that everybody knows is called x, and you go to that variable, right? If I do this and if I run my stuff now, then I'll get an 88. Okay, there's a bit more to globals, but that's now the last one thing I didn't do is you can also define a function. That's important because if you see it, you just don't know. You can say, look, I can say my stuff equals 22. This is not, let's do times 2 function. So times 2 of x equals 2 times x. This is actually, this thing is just like writing function times 2x return 2 times x. Okay, so this is a standard kind of way to write a function. This is very Julia type stuff, kind of, it looks very mathematical. You define the function, but you define it, it's for functions that fit pretty much in one line. But the problem is if you haven't seen much Julia code, you look at this, you say, hey, where's a function defined? No, these 2 bits of code are the same. Okay, all right, our guest speakers outside, enjoy the break. Thanks, everybody. Okay.